Hi everyone, this is Byte Relay, and today we are doing our first interview with database hacker Ruslan Savchenko. Hi Ruslan.
Hello.
And we have 8 questions to you. You can make a short answer or long answer, whatever you want. It's not a very formal interview, just talk whatever you want. So tell us few words about yourself. What's your name? What do you do? What are your hobbies? What defines you?
Okay, so well, as I told, my name is Ruslan Savchenko. I currently work at Yandex as a team leader for development of in-house NoSQL database, or it's better say NewSQL database because it has distributed transactions, but SQL itself is not well so complex as SQL say 92. Well, it's well. Maybe like Impala query language, so you can do some OLTP stuff with this language, but it's not like you can execute rich analytic queries.
Cool. So you're talking about database, but tell something about yourself. What do you like? What do you eat for breakfast? Or what are your hobbies?
Yeah. Today I ate omelette with cheese, I suppose. Well, well, okay. So well, as for okay, you asked about me, asked about my hobbies. So I talk about my job, and as for hobbies, I do teaching at Yandex Data Analysis School. Yeah, I teach computer architecture and operating systems course and database internals course there. Yeah, so
incredible.
We
so you're very relevant for our interviews. And how come you are interested in databases? How did it happen? How did you realize that you want to do databases?
Well, I don't think I ever had this kind of decision. I think what I really was passionate about is like our operating system and something on a compiler level, but I also was interested in algorithms. And after my studies at Moscow State University, my advisor invited me to work at Yandex, and he was building like whole Hadoop stack reimplementation there. It's called YT. You can search it on Hubber. Yeah, and there is a part of this system which acts like a database. So I was working on it for many years, and well, eventually learned some stuff from this area. So that's how it was.
Cool. If it's not a secret, what's the name of your advisor?
He's Maxim Babenko.
Yeah, I know him. Probably I will try to call him to these interviews too.
Oh, yeah, you should.
Okay, so now we tell something about your database, what you like about it, what you don't, how it's called. What's the name?
It's okay. So the whole project called YT, and the database-like part, it's called dynamic tables for some reason. Well, static tables are for MapReduce, and dynamic tables are for key value access. Well, it's kind of hard to explain what I like and what I dislike. Well, really hard to answer. Well, I can tell you some features that it has, and
just a random fact. Something.
Yeah. Okay. So random facts. But well, if we talk about database history, then there were traditional relational databases. Then there were NoSQL systems, and NoSQL systems added distribution but reduced transactions. So there were not distributed transactions for these systems. And then people realized that they would like to have a distributed system with strict distributed transactions. So Google created this, and some new projects started, and the product I work on was initially created as a distributed transaction SQL-like system. So what makes it what made it unique at that time. So currently it's probably unique because it has a strong integration with MapReduce. So basically, if people at Yandex store their data on a MapReduce cluster, then it's convenient for them to use our solution for key value store, because they probably already have data. They can build data in MapReduce and access to it via key value interface in the same system. Otherwise, they would have to transfer the data to some other systems. Well, and well, what I really like about this kind of job is because you can just think, okay, so I know this kind of algorithm, I implement this and it works fine. No, because well, it's really huge. It's like thousands of machines for a team of a few members, and every time something happens, so you can learn in really hard way how the software performs under heavy load, and you can think what to do with it. And for, I suppose, most of recent years, the most challenge to run this system was from these kind of small surprises which occur while you operate this large system.
Okay, thank you. But let's gradually get back to you. What's your working environment? Maybe do you work on desktop or laptop? What also do you use? Or
well,
do you use
I work
IDE?
on a laptop. I don't even use separate screen or a monitor. I happen to have one, but then I ordered the one was really high resolution, and everything was so small there that I stopped using it entirely. So I have this kind of expensive screen on my desk, and I just give it for interns well, who come to work with me. Well, I just use laptop. I have Linux on my laptop. I even do most of editing of coding and editing in GVim. So it's like Vim, but not in terminal, in just another screen. I switched off menu and other necessary panels from there.
Well,
so
what distribution do you use? Is it
well,
Ubuntu?
I use yeah, I use Ubuntu because it was well, pre-installed at work, and I think there was some kind of environmental support for Ubuntu to use Ubuntu internal at Yandex. Yeah, but when I had desktop, I used Gentoo there, and I really like that everything is compiled from sources. So at the moment I want to build something myself, I already have all the headers, and I don't have to install development packets for the things that are already on my system. Yeah, but for working environment, I just use Ubuntu.
Cool. Do you use debugger, something like that?
Yes, and well, usually we use GDB for investigating core dumps. So well,
so you happen to have core dumps?
Yeah,
or maybe
yeah,
you write the bug-free code without segmentation faults.
Yeah. We're really happy to have core dumps. Well, if you can navigate the stack trace, it's much easier to identify what's going on than if it just fails and you don't know where it is. Well, we work on a distributed system, so it's not so easy to work with the debugger online, because if your feature is complex enough, then you will have multiple components to communicate, and I don't know if there is a convenient way to
do you debug in production.
I did well, I did, and there is a funny story with this. Well, I can share.
Every funny story starts with attaching GDB to production.
Yeah, it's it's a thing that the debugger can hit you in an unexpected way. So, okay, everybody can attach GDB to a running process, and you even can add breakpoints to this, and you even can have conditional breakpoints. And you probably think that conditional breakpoints are a very good thing in this case, because, well, what you want to debug? You want to debug some, well, some case, and you probably can write a condition for this case, say username is like this, or well, probably some parameter is like this, and then you want to make a breakpoint. Yeah, but now you have to be familiar with GDB syntax, and it's C-based syntax. So if you write a single assignment in the condition, it works as assignment, and it works as assignment in the running process. So you basically damage the process image with this kind of breakpoint. So that's what I did during my early days at Yandex, and I happened to modify the crucial state of the database. It was not a production cluster, it was some kind of development testing cluster.
Did it result in data corruption?
Yeah, yes. So that was a data corruption.
Sounds scary.
And, well, I think Maxime still remembered it. So he recalls that it should be called debugging with side effects.
Cool. But let's get back from technologies to you, from debuggers and from bugs. How do you learn? Do you have some advice to learners?
Well, I do. So it's well, it's really many stuff over there, and really lots of information that we don't know. So it is in books, it is in articles, it is in blog posts, and well, it's really impossible just to read all these, or probably at some point, and I did that myself, at some point, well, people think that they already know everything relevant to their position, and yeah, and
everything.
and they just yeah, you have this feeling that you just read the same thing over and over. So well, probably if you read some kind of I don't know, well, maybe you read articles on some site for beginners, and then you realize that okay, so it's the same over and over, and nothing interesting. Yeah, but if we look around, there are books with some kind of new information, there are papers with new information. Well, as for me, I think the turning point was when I became teaching. So I started doing this operating system course, and I thought, oh, okay, well, I probably know something about operating system, which should be enough for a course, for an introductory course. It's not a course for real Linux kernel anyway. It's just say operating system design principles course. Yeah, but then I found a piece of information that I didn't even realize it should exist, and found out that well, you should read books, and you should read papers from conferences. Well, if we talk about the database course that I started it with a plan that I read many papers from the past. So it is about this like relational databases. So it's not for new databases. Just 2/3 of the course study relational database design, and well, I read well, early papers like the whole areas paper, for example. Well, as that's for me, and well, for other people, I suggest that they probably should well, look what books people are talking about around them, because they are usually, if there are good books, then people start reading them, people start well, repeating them, showing them over and over, and it can happen that you think that this book is irrelevant to you. So well, there is another story for myself about this. You probably heard of the site reliability engineering book from Google.
Yep.
Yeah, and well, I knew that there is a book with such a name.
I have it right here, but I can't find it. Sorry for interrupting.
Should I continue?
Yeah.
Okay. So yeah, I even heard that it exists, and well, I had advices that I should read it, but well, I also heard an opinion that this book is for managers, so it's not for developers. And well, I consider myself as a developer, even if I were a team leader already at the moment. Well, come on, I'm a technical guy. Why should I read this stuff for managers? Yeah, and well, at some point later, I opened this book, and I was stuck that all my problems, all the thing I worked on intuitively, all the problem I experienced, they were in there. And if Google had these kind of problems, why should we avoid? How can we avoid them? Yeah. So we could be more prepared if we knew that, okay, Bigtable is a great software. Bigtable, is explained in a 20-page long paper how to implement it. Yeah, but that paper doesn't say that there were many problems when Google
probably doesn't describe
yeah,
feature incidents.
Well, I read like a paragraph from this book and realized that, okay, so they had the same problems with storage, the same problems with how they access the storage, and we had them too, and we worked on them. Yeah, but it was interesting that they also experience this problem. So I realized that well, it's good to read books not only from your topic but from different topics.
I understood. So basically, to condense what you said, that first you are learning by teaching, and you recommend doing so to others. And second,
I also recommend these to others. I really recommend.
Second is advice that you recommend learning stuff that seems irrelevant just to try. Cool. Okay, let's move on. And final question: are databases a solved problem? Are we going to hack on this forever, or at some point we'll finally implement database?
Forever. This no, database is not.
Sound pessimistic.
Database is not solved. No, because database. So what is a database? It's actually an essence that you have a data on some kind of hardware, and you have a user who want to access this data, and users want to access this data efficiently, both in terms of how they express their query and how much hardware resources it should be taken to answer this query. And I think that for people who are interested in algorithms, they now realize that, okay, there's infinite development in algorithms, data structures, so it should be infinite development for database on this part. Well,
but people at some point, people just good enough.
Just good
enough database.
Well, so it should be enough. Well, let me continue. So, I think people who most work on compilers and on languages also think that, okay, this SQL language probably is not enough, and there are kind of other things that that people can think of accessing the data. Well, probably some even want to use natural language to express how to access the data, and there are startups which like promise they could do this. Yeah, but there is another consideration. So there is ongoing progress for hardware. And if we look just 10 or 20 years in the past, then well, hardware changed dramatically. Well, we have multi-cores, we have so many cores on a single CPU that we even need to think about topology of these cores, so they are not so connected to each other. And if you look at the storage, their main place for data to store, there also was a really huge development. And well, things change on this part, and if the data is stored on a different hardware, then you probably want to access this data in a different way, in a different size, probably with different data structures. And well, I don't see quite an end here. So it's not like we have a software which works best for all kind of storage systems. So we have databases which work best for HDD. We have something for SSD. We have another solutions for main memory, and well, all they are different from each other because well, they internally they are implemented in a different way. And well, when you build a system that is well, works great for all existing hardware, then something else appear. And
okay, the world will change, and we will adapt our software to it.
I don't think that there will be end for databases.
Cool. So we will hack forever. Let's continue like that.
Yeah.
Okay, thank you very much. That was so inspiring interview. I think I'll share it right now.
Thank you for having me. Yeah.
Thank you very much, and have a nice day. Goodbye.
Bye.